In this video, we will be using the second derivative test to examine the concavity of a function. This first example is a piece of a curve that's concave up. In this example, this is a piece of a curve that's concave down. The graph of f is concave up if the second derivative is positive in a given interval. The graph of a function is concave down if the second derivative is negative in a given interval. To use the test for concavity, we first locate the x values where the second derivative is equal to 0 or does not exist. Then we determine test intervals and test the sign of the second derivative in each of those intervals. The example that we'll be doing is determine the open intervals on which the graph of f of x equals the quantity x squared plus 1 divided by the quantity x squared minus 4 is concave up or concave down. So to begin this problem, we have to find our derivative. So f prime is equal to, and we'll need to use the quotient rule. So we have the bottom, x squared minus 4, times the derivative of the top, which is 2x, subtract the top, which is x squared plus 1, times the derivative of the bottom, which is 2x, over the square of the denominator. Now let's simplify this a little bit before we take the second derivative. We distribute this 2x through the binomial, so x squared times 2x is 2x cubed. Negative 4 times 2x is a negative 8x. And then I'll distribute the negative 2x through this binomial, so I have a negative 2x cubed and a negative 2x over x squared minus 4 quantity squared. Looks like these cancel. So my first derivative is negative 10x over the square of x squared minus 4. So my second derivative is the bottom times the derivative of the top, which would be negative 10, subtract the top, which is negative 10x, times the derivative of the bottom, which is 2 times x squared minus 4 to the first power times the derivative of what's inside, which is 2x. And that's over the denominator squared, so to the fourth power. We multiply exponents. Let's simplify this a little bit. I'm going to leave this for the time being because I'm going to have an x squared minus 4 that I can cancel with one of these down here. So I have a negative 10 multiplied by x squared minus 4 raised to the second power, and then plus 2 times 2 times 10, so 40, and then I have an x times an x squared, and then my x squared minus 4. So I'm going to take one of these binomials and cancel with one of these. So that leaves me with a negative 10 times x squared minus 4 to the first power plus 40 x squared, and that one's gone. And then in the bottom I have x squared minus 4, and that's now to the third power. My second derivative is equal to negative 10x squared plus 40 plus 40x squared all over x squared minus 4 raised to the third power. Combine terms here, one last simplification. F double prime equals 30x squared plus 40 over x squared minus 4 raised to the third power. Now we need to set this equal to 0. I'll just put that over here. And then look to see where this second derivative is equal to 0 or undefined. So there is not going to be an x value that causes the second derivative to be equal to 0, because this will be a positive number here, and adding 40 to that will never give me a 0. So the only thing that we can use will be when this denominator is equal to 0. So x squared minus 4 equals 0 when x squared equals 4 and x is equal to plus or minus 2. So then that splits our interval. We now have an interval from negative infinity to negative 2, from negative 2 to 2, and then from 2 to infinity. So a test value negative 3 would work. Test value of 0 in the middle there, and then a test value of positive 3 on this interval. So I want to check my second derivative at negative 3, at 0, and at 3. Let's see, let me enter my test value, or my second derivative here, and then I'll move the calculator out of the way. So I have 30x squared plus 40 divided by x squared minus 4, that's cubed, And then now let's enter our -3 stored in for x. See what that second derivative value is going to be. 2.48. 0 stored in for x. -0.625. And then 3. 2.48. So when my second derivative is positive, we have concave up. When my second derivative is negative, we have concave down. And when my second derivative is positive, that's concave up.